Dear students, ഇന്ന് നമുക്ക് ഇലക്ട്രോണിക്സിലെ യൂണിറ്റ് 1 സെമികണ്ടക്ടർ റെക്ടിഫയേഴ്സ് ആൻഡ് DC പവർ സപ്ലൈസ് എന്നുള്ള യൂണിറ്റിലെ ഫസ്റ്റ് ടോപ്പിക് ഡിസ്കസ് ചെയ്യാം. ദാറ്റ് ഈസ് ദ പ്രിലിമിനറീസ് ഓഫ് റെക്ടിഫിക്കേഷൻ. റെക്ടിഫിക്കേഷൻ എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ ഡയോഡിൻ്റെ ഡയോഡ് യൂസ് ചെയ്തിട്ട് നമുക്ക് കൺസ്ട്രക്ട് ചെയ്യാൻ പറ്റുന്ന ഒരു ഇലക്ട്രോണിക് ഡിവൈസാണ് റെക്ടിഫയർ എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ. അപ്പോൾ ഡയോഡിൻ്റെ പ്രോപ്പർട്ടി നിങ്ങളെല്ലാവരും ഓർക്കുന്നുണ്ടാവും. A diode, it is also known as a PN junction. It has two parts. One is the anode part and the other one is the cathode part. When a PN junction is formed, a potential barrier is established at the junction. So this potential barrier, it does not allow any further movement of holes and electrons through the junction. അതായത് പൊട്ടൻഷ്യൽ ബാരിയർ ക്രിയേറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ PN ജംഗ്ഷനിൽ ഫർദർ മൂവ്മെൻറ്റ് ഓഫ് ഇലക്ട്രോൺസ് ആൻഡ് ഹോൾസ് ആർ നോട്ട് പോസിബിൾ. ഇൻ ഓർഡർ ടു കണ്ടക്ട് current through the PN junction diode, we have to connect an external supply, the external battery we have to connect. The battery, suppose it is a DC battery, the voltage variation and along with the time will be like this. That is, as time varies, there is no change in the voltage. Voltage remains as a constant. This is the case of a DC source. Usually battery is a DC source. There is no variation in the voltage with respect to time. So this battery you can connect. The symbol for a battery is like this. This is the positive terminal of the battery and this is the negative terminal of the battery. A battery we can connect in order to overcome this potential barrier. And this battery you can connect in two different manner. One is the forward biasing manner. In this case, we are connecting the battery to the diode like this. That is, the positive terminal of the battery is connected to the anode part and negative of the battery is connected to the cathode part. In this case, we have seen that the height of the potential barrier decreases and there is an easy flow of current through the diode occurs. If current flows easily, then resistance in this case it is very low. Resistance is very low and it is of the order of some 25 ohms like that, and we usually represent that diode resistance by the symbol RF. That is the forward diode resistance. In practical case, we can neglect this value is very small, so we can neglect this value. And the second case is the reverse biasing. In the case of reverse biasing, we are connecting this diode like this. That is, negative terminal of the battery is connected to the anode and positive terminal of the battery is connected to the cathode. So in this case, we have seen that the height of the potential barrier increases and because of that there is practically no current flow through the diode takes place. No current flow through the diode, and so in this case resistance is very high. So these are the two cases of biasing in the case of a diode, PN junction diode. Now in this case, suppose we are current is flowing through this PN junction diode. Since the resistance here is very low, the voltage drop across the diode voltage drop across will be very low because resistance in this case it is very low. So the voltage drop across this diode will be very low. But in this case, what happens is R is very high. So what happens? R is very high means the drop across the diode, that is I into R, it is very high. So there is a chance of this diode to break down. So diode has a special characteristics voltage that is known as the peak inverse voltage. That is the peak inverse voltage, PIV. It is the maximum reverse voltage that a diode can withstand. So in this case, the maximum, whatever is the voltage applied here, since there is no electronic component in the circuit, whatever is the voltage applied here, that will be come across this diode. So what happens? All of the potential applied here will be across the diode. So we have to know about the reverse voltage, peak inverse voltage of this diode, in order to avoid the diode to avoid it from the breakdown to damage. So what happens? We have to have a clear idea of the peak inverse voltage of a diode if it is coming in the reverse biased manner. There is no such a case occurs in the case of forward biasing, because it acts as just as a conductor in this case. There is a very low resistance, easy path of current takes place through the diode. Now we can come to the case of rectification. Rectification, in the simplest case, we can say it as the conversion of an AC into DC. Usually an AC supply, we are representing it in the diagrammatic manner like this. Here, along the x-axis, we are representing the time, and along the y-axis, we can represent either voltage or current. Both the variations of voltage and current are in the same manner. The values will be some difference will be there. Now, this AC voltage contains positive variations and negative variations, and the period of this AC is 2 pi. From 0 to 2 pi, the variation, we can say it is positive, and from pi to 2 pi, the variation is negative. Now, in order to convert an AC into DC, we can use the property of diode. So first of all, suppose we are using a single diode, and by using this circuit, you can design a rectifier circuit, and that rectifier circuit will be like this. It is known as a half-wave rectifier. Half-wave rectifier. Now we can discuss the working of this half-wave rectifier. So what happens here? So this is the AC supply, and this we call it as the load resistance. Load resistance. Along this load resistance, we are taking the output voltage. This AC supply, which we have applied in the input, so it is also known as the input supply. Now what happens? This input AC has positive half cycle and negative half cycle. Suppose at this terminal the polarity is positive, so what happens? This end will be negative, and the diode, at the diode we will get positive voltage. At the anode part we will get the positive voltage, and the cathode part we will get the negative voltage. So during this time, the diode contacts, and the output we can represent like this. So from 0 to pi region, it will be like this. It will conduct easily. Now after reaching this particular phase part, or after a particular time interval, the polarity suddenly changes like this. This end becomes negative and this end becomes positive. So the polarity at the diode also changes. So here this negative is connected to the anode and the positive is connected to the cathode. So the diode is in the reverse biased manner. So practically there is no current flowing through the load resistance, and suppose we take the current across the, or the voltage across the load resistance, there is no practical voltage or current across the external load resistance. So when the cycle repeats, so what happens? This type of waveform gets repeated. Now since this diode conducts only during one of the half cycles of the input AC, so this is known as a half-wave rectifier. So we don't have this part in our syllabus, so we are dealing with the next type of the rectifier, that is a full wave rectifier. Full wave rectifier. And this half-wave rectifier has a lot of disadvantages, because only one of the half cycles of the input AC is used here, and we are getting only output for during these each half cycles only. So we are modifying the circuit in order to obtain the output during the two half cycles. So for that we have to use two diodes, and we have two types of full wave rectifiers. One is the center tapped full wave rectifier. Center tapped full wave rectifier. This circuit, we are using two diodes. We are using two diodes connected like this. Now we need an AC supply, and that AC supplies is given to the primary. This is the primary of a transformer, and this is the secondary of a transformer. This is the AC supply. Then we are connecting this lead to here. This is the center tapped one, so one more lead is there, and that we have grounded, and from this point, common point, we have connected the load resistance, and the end of this load resistance is connected to the center tapped. That is the meaning of this ground terminal. Now next we can discuss the working of this circuit. So since this is an AC supply, at a particular instant of time, this end becomes positive and this end becomes negative. So we can deal with the two diodes. What happens during these half cycles of the input AC is that diode D1, in the case of diode D1, this anode is connected to positive and cathode is connected to the negative part. So this diode D1 conducts. This is our input AC. We can represent like this, and suppose we represent in the output voltage like this. This is our input and this is our output. So during the first half cycle of the input AC, D1 diode will conduct and D2 is reverse biased. That is anode here connected to the negative lead. So this diode D1 conducts and D2 does not conduct. So a current flows through this external load resistance. And what is the direction of this current through the external load resistance? The current flow is always from the positive lead of the battery to the negative, or from the positive lead to the negative lead. So the current flows along D1, then comes here, then flows through RL, then reaches this point, then comes here and repeats this path. Because there is no current flow through the diode, this is a high resistance path. Current does not take the high resistance path. So the direction of the current you can mark like this. It is from the top to the bottom. Now, so because of that, we will get an output like this. It is in the same manner as that of the input part. Now, at the next instant of time, this polarity of the leads changes. So what happens? This D1, at the anode of the D1, we get negative polarity, and at the anode of the D2, we will get a positive polarity. So this D1 is in the reverse biased manner and D2 is in the forward biased manner. So during the next half cycle, D2 will conduct and D1 will not conduct. This is the case. The case is reverses. So what happens here? The current conduction, we are taking the output across RL. So we can find out the direction of the current through RL. So it is from positive lead, starting from here. Then it comes here. This is a high resistance path. It does not take this path. Then this current will flow along RL in the same direction as in the earlier case. And this closed path completes a closed path. So again, the current through the load resistance is in the same manner. So we can represent like this. So this type of a wave, we are getting a wave like this in the output. So it is known as a full wave rectifier. Okay, then this full wave rectifier, we can study the case of full wave rectifier in a detailed manner. So what happens here is this D1, at some instant of time, D1 conducts and D2 comes in the reverse biased manner. And at some instant of time, D1 comes in the reverse biased manner and D2 is forward biased. So there is a chance of the two diodes to become reverse biased in the reverse biased case. So we have to take the case of the peak inverse voltage. That is, suppose we have a voltage Vp here. That is the voltage between one of the terminal and the center tap of the transformer is Vp. And from here also there will be Vp because it is the center part of the transformer. So at a particular instant of time, this voltage will come across along a diode. This voltage will come across this diode, and this voltage will come across this diode. So the two diodes attains a maximum value of Vp during the reverse biased case. So in order to avoid the diodes from the breakdown, so we have to take the peak inverse voltage of these two diodes such that peak inverse voltage of the diode is greater than Vp. So that is an important case in the case of the important result in the case of, or important factor which we have to note in the case of center tapped full wave rectifier. That is the diode which we have considered should have a peak inverse voltage which is greater than the Vp. That Vp is nothing but the voltage between one of the terminal and the center tap of the transformer used in the center tapped full wave rectifier. Now, suppose we are analyzing this circuit, we can say that it is a simple circuit which uses only two diodes and a single resistance. And another defect which we can say is that it uses we can use only a center tapped transformer in this case. Otherwise, the circuit will not work. So in order to avoid, sometimes this voltage, there will be some voltage difference between the upper part and lower part. So there will be some variation in the nature of the output waveform. So in order to avoid that, we are modifying the circuit and we are designing another type of circuit that is known as a bridge rectifier. Bridge rectifier. In the case of bridge rectifier, we are using 4 diodes, and these diodes we are connecting like this in a bridge manner. Now we are connecting like this. It is connected in a bridge manner. That is 4 diodes are formed. That is D1 here, D2 here, D3 here and D4 here are connected in such a manner that this D1 and D3 opposite arms have the diodes connected in the same manner, and we are connecting it to an input AC through a transformer. AC supply here, then we are taking a transformer primary we have, then we have the secondary is taken, secondary terminal we have, then we are connecting the external load resistance here. External load resistance is connected here, RL. Then we can name the diodes as D1, D2, D3, D4, etc. Now as in the earlier case, we can discuss the working of this bridge rectifier. So at a particular instant of time, suppose we take this end as positive at a positive polarity, then this end will be at the negative polarity. Now we can consider the case of 4 diodes. What happens to the case of D1? D1, in this case, D1 is forward biased. Then the case of D2 is it is connected, anode is connected to negative, so it is reverse biased. Then for D3, it is negative is connected to cathode, so it is forward biased. Then for D4, it is a positive is connected to cathode, so it is reverse biased. So at a time, at this instant of time, D1 contains and D3 contains. So we can consider the path of the circuit like this. Starting from positive terminal, the current flows through D1 and reaches this common point. Then on reaching this point, it selects the easy path, that is through RL. Then these 2 points are the same. Then reaches here. Then on reaching this point, it selects this path, D3 path. D4 is in the reverse biased condition. So the complete path closes. So the current flow along the external load resistance will be like this. Now if we represent the output and input waveforms, this is the input waveform, and the output waveform for the positive half cycle, we will get the exact same waveform in the output also. Now during the second half cycle, what happens? The lead polarity changes and this end becomes negative and this end becomes positive. When this end becomes negative, suppose we take the case of D1. D1 is here anode to negative, so it is reverse biased. Then here positive to D2, so anode, so it is D2 is forward biased. Then what happens to D3? D3 positive to cathode, so it is D3 is reverse biased. Then what about D4? D4 negative to cathode, so it is forward biased. So in this case, D2 is forward biased and D4 is forward biased. So other two diodes is in the reverse biased case. So what happens to the flow of current? Current starts from here. It selects the easy path. So along D2, then reaches here. This is a high resistance path. So select this path, then reaches here. On reaching this point, it selects this path. So external current is along the in the load resistance is in the same manner. So we will get the output in the it is the wave nature is the same, but it is in the variation is in like this. It is varies only in the positive manner. So this type of a waveform we will get in the output. So it is known as a full wave rectifier. Now in this case, we have to take the case of peak inverse voltage. So here at a time D1 and D3 becomes reverse bias, and at a certain other instant of time D2 and D4 becomes reverse biased. So suppose Vp is the voltage between these two terminals of the transformer. At a time what happens, the maximum voltage that is obtained at a diode, it will be Vp. So we have to select diodes which have a peak inverse of voltage of the order of which is greater than Vp. That is a special case here. Here it is a peak inverse voltage is here you have to take this time if it is Vp here, there is a slight modification here. Here only we have considered this voltage, so 2 times Vp here. Here it should be peak inverse voltage should be greater than 2 Vp, and here it is peak inverse voltage is greater than Vp, but there is a difference between this Vp and this Vp. This Vp is the voltage between two terminals, and here the voltage is between a single terminal and the center tapped transformer. Now the advantage of this circuit is that it uses 4 diodes, and we does not need a center tap transformer. You can use a common transformer here. Then peak inverse voltage, the rating is will be low. Here it is 2 Vp, so here it is Vp. So in this case rating is low in the case of bridge rectifier. We can use a low rating diodes in this case of half a rectifier. Then another factor which you have to note in this case is that about the output frequency. The output frequency is the number of repetitions in a particular cycle. So here this is the repetition part of the output waveform. So whenever this wave repeats one time, this wave repeats 2 times. So frequency will be that of the 2 times input frequency. So these are the points which we have to note in the case of rectifiers. We have 3 types of rectifiers: half wave rectifier, full wave rectifier, and bridge rectifier. Half wave rectifier, it contains only for the one of the half cycle, and the output will be very low. So the practically the efficiency of this circuit will be there is a tendency for the efficiency to reduce in this case. In this case it conducts for both the half cycle, so the efficiency will be very high in these 2 cases. And certain advantages are there for full wave rectifier, and certain other advantages are for bridge rectifier, and certain disadvantages, that disadvantage has been rectified in the case of bridge rectifier. So that is all about this rectification. Okay.